Hey guys, welcome back to my video series on solving LeetCode problems. On this video we're solving problem 30, substring with concatenation of all words. So what's this about? You're given a string s and the array of strings words. All the strings of words are of the same length. This is important. A concatenated substring in s is a substring that contains all strings of any permutation of words concatenated. For example, if words A, B, C, D, E, F, then you have all of these combinations like A, B, C, D, E, F, A, B, E, F, C, D. Here it is. So all combinations of this. And you need to return the starting indices of all the concatenated substrings in S, and you can return the answer in any order. So, for instance, in bar foot, the foot bar man, you have the words foot and bar. And you can rearrange them in two ways. You can do foo bar and then bar foo. So you have bar foo here, index 0, because that's where it starts, and foo bar. And this index here is index 9. So you just need to return 0, 9. Same thing here, word, good, 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 best word. Word, good, best word. So we have word twice. Nah, there's no such thing here. Because you need to have the word. The word should be present twice. And this is as close as it gets. Okay, so let's implement this. Actually, first of all, let's open JS Paint and let's explain how to do it. So I actually recorded a video where I did one of the versions of this solution that worked. However, it reached a timeout on a specific case. And the reason why was I was doing array modifications instead of having counters and doing subtractions. So I stopped the video and re-recorded it. So, with no further ado, let's go to the strategy. So, let me just go here and copy bar foo, the foo bar man. And we have foo and bar. So, we know that the combination here, we check the length of the words. We have 2 words. We already know that they must have all the strings of words are of the same length. So, we can just go and say, hey, if we check the length of the first one, we check how many words we have. We have 2 words, length 3, so the combinations must be of length 6. In that case, we create a window of length 6. And then we just move the window all the way to the end of the string until we find combinations of foo and bar. So we start here in the beginning, bar foo is a combination of foo and bar. Good. We add index 0. So we move on, R for the nothing, and then we have foo bar. Oh, this is a good one. The index is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Nice. And we continue running it, and we don't find anything. Okay, so this is how we do it. However, the tricky part here is not to get the timeout, and how not to get the timeout. So, we need to check if bar foo is a combination of foo bar. So, how can we do this? We can just iterate over the blocks of the length of the words. In this case, it's length of 3. We have 2 blocks of length 3. And then we need to check if the word on the first block is part of words, and then the same for the second one. If both are true, then we consider this to be a combination of foo and bar. However, let me just give another example. What if we had foo bar foo? something like this. Then our window would be free, length free. However, there's a problem here, and the problem is that we can't just see, oh, let me check if the first word is in this list, second one, third word. Why? Because if we check, let's imagine it was bar foo bar, something like bar foo bar. Let me just move this. Bar foo bar. So you go to the first one, and it's like, yeah, it exists here, so good. Second one, yes, it exists here. Third one, yes, it exists, and it's valid. However, bar foo bar is not a combination of foo bar foo. So bar exists, foo exists, and then bar doesn't exist twice. So it fails. How do we do that? We need to use something like a counter. Counter, which is bar equals 1 and foo is 2, because we have foo, 2, and bar, which is 1. So what we need to do is go, hey, does bar exist here? Yeah, good, then this one becomes 0. Foo exists, good, then this one becomes 1. So let me just go do it. 1, that bar goes 0, foo is 1. Next one is bar. Oh wait, bar is already 0, so this can't work. So this is the way to go. So let's implement this. So first of all, we need to know, we're going to iterate over the window. Let's create the window. Window left index is 0. Window right index is length of s. No, sorry, not length of s. It's the length of words times the length of words 0. So this is the first thing. And now we do while, let me see, while window right index is smaller than length of s. I think it should be smaller or equal though. Smaller or equal. Because we were doing the following things. We will be doing something like current window, and that is s of window left index, window right index. So now what we need to do is we need to split the current window into chunks of 3, and then we need to check if those chunks of 3 are all present in words and if the counts match. So I'm actually going to do something. Word counter equals counter of words. This will count me the words. And at this moment, I'm going to do something different. I will work with the optimization that I did so we don't reach a timeout. So we do new words counter, because we're going to be modifying the counter, and I don't want to modify the overall words counter and then have the counter being initiated again. So I'll just do counter of word counter. This will save on resources because it will just copy word counter. New word counter. So We won't do current window, but what we can do is for I in range let's see, length of words. So current word equals S of, see, window left index plus I times length of words 0 all the way up to kind of like the same thing, but for the right index. No, wait, no, I'm saying something wrong. I want the left index plus that, and then the same thing, window left index, because I just want to calculate this. I'm iterating through this, and then this, and then this, so I just need to use the powers, the multiples of, in this case, 3, which is the length of these words. So length I times, so I'll just do I plus 1. Okay, good. So let me just do print current word and then print something. And now word good, good, good. Word good, good, good. Makes sense. The next one would be org. No. Oh, right. And the last thing we will need to do is window left index plus equals 1 and window right index plus equals 1. So word good, good, order, good, good, best. And we just do until we end with good, good, best word, which is the last one. Good, good, best word. So at the moment, what do we need to do? So we know we're separating the words correctly. So what we do is if new word counter of current word is equal to 0, then break. Else, what do we do with the else? We do a new word counter of current word minus equals 1. So what happens if it never breaks? If it never breaks, it means all the counters were reduced to 0 because all the words were visited, and then well, that's actually not true. Is it not true? Current word, new word counter. Oh yeah, now what we need to do is say else. No, that's actually true, because there are like a lot of, there must be the same number of words being iterated here, because it's length of words. And if there's one word that is not there, or that is there too many times, it will go under 0 and then break. So we don't even need to check anything. If this cycle ends without breaking, then we know that this is a right combination. So else we do return values. Values equals empty string and return values out of pens window left index. And then at the end we just do return values. And that's pretty much it. That's all we need to do. Return values is 8. Let's just copy and paste it and submit it. See if it works. Well, it worked. Great. So, for some reason it did a lot slower than my previous submission. A little better memory, but you know LeetCode, you just submit again, you wait, and then you might get better results. Let's see. So what did I do different? Oh, I had this thing here, so I had this quick check that let's see if the size of S was bigger than just the size of words. Not sure if this will change, but this is definitely an edge case that we can check beforehand. And then everything else is pretty much the same. So let me just try this and see if it helps. No, it didn't. I'm just going to copy the old code and submit again, because there must be something that I did there that I didn't do here. Some kind of optimization. Yeah, looks like I did. So, same thing, counter. I have window size here, similar. Here with counter equals counter. For current word range. Oh, I did it differently. I did this cycle. That's kind of like the same thing. Equals 0, else. I don't know what I did different. But yeah, it works. So I hope you guys enjoyed it. See you later.